So this is lab 1, charged tape. So the purpose of this lab was to prepare charged pieces of clear tape, observe the interactions between tape and other objects, whether they be neutral, positively charged, or negatively charged, and to determine approximately how much excess charge is on one piece of charged clear tape so that one piece of tape floats above the other. And the two concepts that were used in this lab are electric force, which you can see by the equation down in the lower left, that the magnitude of the force is equal to the K constant times the charges of the two objects divided by the distance between them squared. And if you were trying to make a vector, you would just multiply this by the unit vector from source to observation. And we see electric field, which is the middle picture. You see that if it's a positively charged point, the electric field points outward, and if it's negatively charged, it points inward. And the image on all the way on the right is just showing that positive and negative attract while same charge signs repel. So when doing the lab, the interactions that I found were that the two U-tapes repel each other, which makes sense because they would have the same charge, and that the U-tape and a negatively charged pen attract, which means, as from the last slide, positive and negative attract, and since pen is negative, then the U-tape must be positively charged. And so some assumptions we made to actually do the floating tape part is that each U-tape has the same net charge, so they have the same charge, and that the charge of each tape can be treated as a point charge, rather than a bunch of charges scattered along the entire area of the tape. And the results that I got from the lab is that the length of tape B, from this image on the right, the length of tape B is 12.5 inches, or 0.3175 meters. The mass of the tape, based on 1 gram per meter, is 0.003175 kilograms. The distance between the tapes, so the distance from A to B, was 0.0508 meters. And based on mass times the G constant, the magnitude of the gravitational force on tape B would be 0.00311115 newtons. And since the tape is floating, the magnitude of the electrical force of A on B would have to be the same, so 0.00311115 newtons. And here's the calculations I made to do this. So as you can see, here's the mg, so mass times gravity, and we set that equal to the force, the electric force. So the K constant times Q squared, since we said both pieces of tape have the same net charge, times the distance between them squared, and then the unit vector 0, 1, 0, because one tape is directly above the other. And by solving this for Q, you find that approximately the amount of charge on one piece of tape to get them to float is 2.987 times 10 to the negative 8 coulombs. And the code that I used to make sure that I did this right, so I used it to calculate and estimate the amount of charge on each tape necessary to float one tape above the other, and I created a visualization of the system. And for the initial values, I used the results. So like the mass of the tape, the distance between the tape, I used what I found in the experiment. And as you can see, the computer calculated the same magnitude of charge, so 9.8695 times 10 to the negative 8. And some assumptions I had to make, just as I did for the experiment, were that I had to treat the tape as point charges, and we'd assume each tape had the same charge, but not that they were spread evenly along the tape. So as you can see, the blue point would be the lower tape, the green point would be the upper tape, and that's why they're point charges, and the red vector would be gravity, orange vector would be electrical force. And some discussion questions. So first, what if the electron had positive charge, protons had negative charge? What would happen to our observations if this was true? So the tapes would still repel because they both have the same sign still, except it would just be positive, negative. But this time the tape would repel the pen because the tape would have a negative charge instead of positive charge, which would repel with the negative charged pen. And why is it important to handle the charged tape as low as possible? because handling tape as little as possible prevents the charge from the tape to be transferred onto any other objects like our hands, which allows for more accurate results. And when it does come in contact with the hands or other objects, the electrons transfer from the tape to the object, which can cause the tape to lose its charge and you have to recharge the tape. So in conclusion, objects with the same sign charges repel, objects with the opposite sign charges attract. And for the tape to float, the magnitude of the electro force must be equal to the force of gravity, and electrons can be transferred from one object to another.